Now we're going to extend the area model and look at a model using just angles. So spinners can also use an angle model. I don't have to do area. I can measure how many degrees. And I have this neat application at Shodor that you can try out. Now this is a virtual spinner available at Shodor, so I can actually increase the sections or decrease them. For right now, I'm just really interested in working with a particular angle. So I've decreased the sections to 2 sections. And I'm going to make this so that's about 90 degrees. All right, so that's 90 degrees here. And if I spin it, I can go ahead and spin, and but let me go ahead and do 100 spins. All right, so the question is, how many times would I expect the pointer to land in this blue section? So let me hit spin, and it's simulating 100 spins. And the theoretical and the experimental, wow, that worked out to 25%. I got 25 spins in blue, 75 spins on pink. Will that always happen? Well, let me see. Let's try that again, and let me do a new experiment and run it one more time. So in this case, I didn't get exactly the theoretical. The theoretical is 25%. In this case, I got 19 and 81. And let's do that again. And I got 19 and 81. Do you think it'll happen again? 26 and 74. So if I did, say, go more spins, let's do 500s, okay? And we'll do a new experiment and spin. There I'm getting a lot closer to theoretical. I got 124 in blue and 376. If I do a new experiment again and spin, there I'm pretty close. So again, the actual, what you observe can change depending on how many spins you do. So if I only do a few spins, there's no guarantee that I will be anywhere close to theoretical. Let's say I did 4 spins only. Well, in that case it was, but if I do it again, I could have, look, all 4 were in pink, so I didn't match theoretical. The main point of this whole thing is that using the angles, this is a 90-degree angle, and what fraction does that make from 360? Well, that's 1/4. So I would expect 1/4 of my results to be in the blue and 3/4 to be in the pink, which is pretty much what we were seeing, as long as we had a sufficiently large number of spins. And this leads to the general angle model. The probability of landing in that section of a spinner is basically the angle over 360, or part to whole. In this example, I'm going to use a spinner and calculate some probabilities. And I'm going to use the angles instead of doing areas. So for the probability that I'll land in section A, the angle there is 120. The total is 360. So the probability is 120 over 360, which I can simplify to 1/3. Now the probability for section C, that angle is 40 degrees. The total is still 360, and that probability is 1/9. So reflecting further, how is the angle model similar to the area model for geometric probability?